planning to do a presentation for you. We were planning to do some Q&A.
What's your name?
Oh, sorry. I'm Keenan.
My name's Eric Berger.
He's wearing his name tag. Got to find one. So we wanted to open it up to questions about what we're doing.
You guys are able to focus financially. How are you able to focus on the long term?
I'm going to put that off to Steve. We're really here to talk about what we're doing as far as releasing the robots, the open source story, the fact that we have this workshop, which is an incredible chance for us to take 11 of the top robotics institutes, bring together multiple professors at each of those groups, have them bring their strongest students here for a week, all get to know each other, all get to know the same platform, and then spread out all over the world to work on everything they want to do. This workshop that we're teaching this week, I think, is an absolutely incredible thing that we're doing. The stuff that's happened over the last couple of days has been fantastic. They've had the robots at this point for basically 2.5 days. And people have already made it do new things. People have been visualizing sensor data in new ways. People have been doing experiments with teleoperation, just driving under remote control. People have been detecting locations of tables. People have been integrating this with existing planners. It's amazing to see. Robotics is a place where generally progress happens very slowly, and the last couple of days we've seen a ton of new stuff happening. We're hoping to continue to see that over the next 2 years.
How does this differ than the early work of the Robotics Institute at Carnegie Mellon? What's different about your model? Does it play off of that for those of, you know what I'm talking about? Carnegie Mellon's an excellent robotics institute. Carnegie Mellon and many other robotics institutions around the world that are academic are generally, they operate on the academic model. You have a bunch of professors. Professors are generally working to write papers. Now, you research, you find new things, but they're not, none of them have the resources to sit down and create a new platform like this, and none of them can think about it and sort of put the engineering and the industrial focus on it that you really need to make something like this fly.
Can you talk about the format of the workshops?
Yeah. So the workshops, it's 5 days. Each team is bringing 6 people, and basically they have 6 people and the robot. We're spending 3 of the days teaching them about different systems of the robot. So an hour teaching about how to do navigation, an hour teaching about how to do calibration, an hour teaching about how to control the arms and the head, an hour teaching about how to read sensor data, how to read 3D laser data. And then we have a couple days for them to do anything they want while they basically have us here to answer questions. Because a lot of the time, just knowing how to get started is that thing that's really hard to do. And so we want to get them over that hump so they really own the robot and they can do their own things with it.
And are they all working together or just in the teams?
Are
all the teams working?
They're working with their teams, but also working together.
What's your metric for success, just for this week and as for the whole opportunity altogether?
Sure. So we see personal robotics as the next paradigm-shifting productivity tool for literally mankind. I mean, when we talk about that, we're talking about, automobiles, agriculture, that kind of thing, as far as the potential for change. We're literally talking about taking automation, which today, people in factories have access to, and giving it to the rest of the world, which turns out to be most of the world that doesn't have access to that kind of automation in their everyday life. So that's what we're shooting for. Our first step, in our open source platform and our hardware platform, we think is the first step to get there, is taking what is now a very disparate community and bringing them together. Or I guess not even now, but what used to, about a year ago, was a very disparate community, is already coming together around the raw software platform, and also making code sharing easier by providing a hardware platform. I think is the first step to getting us there.
Thanks. I know that the key element of the PR2 is the software, but I'm wondering if you can spend just a minute talking a bit about the hardware and the sensor array and how adaptable it is to different applications.
Sure. So, we have a whole design process we go through. We look at all the application space and basically all the types of applications people want to do, from the home to industrial applications. And we've basically analyzed them and tried to figure out what sensors you need to be useful across these applications, how to design arms that are useful across these applications, and how to make the system flexible across these applications. So we have sensors tailored to various things. That's why there's a lot of sensors on the robot. We have very capable arms that are very useful in a lot of these applications. I'm not sure if I answered your question there, but that's sort of that's where the thinking comes from.
Okay, and maybe later we can get a list of this sensor array, or is that available somewhere?
Oh yeah, sure. On our website we've got that up. Yeah, absolutely.
Okay, great.
Yeah.
And the very quick run through is a couple sets of stereo cameras, including the new texture projector, and 3D scanning laser rangefinders. Both of those are for building 3D models of the world. regular cameras in the forearms and the heads, an inertial measurement unit, which measures how the robot is moving through space, sensors for position of all the joints and the ability to control the torque, so the robot knows where it is in space, and fingertip sensors are the primary sensors.
Thank you.
So, $400,000 today, what's the goal? Or when you want to price it and how far away is that goal, do you think?
So you have to, I mean, we're very practical in our thinking, and the market today for robotics like this, for robots like this, is the researchers we built this robot for, and the developers we built this robot for. The expectation is that, just like in the computer industry, when you had very expensive mainframes and very expensive workstations, and you had that evolution, we'll see the exact same evolution happen. And we're already seeing people that are taking ROS and making robots a lot like PR2, but have potential to be less expensive. They're starting to put together plans to take those steps. So we're very excited about where it's going to go. And yes, lower cost is one of the first things that has to happen.
You don't have a target in mind right now?
I'm going to say similar to a car, but stand back as to whether we're talking luxury car or used motor.
Yeah, if it's a Tesla, that's a different story.
So related to that question, and it was said by Steve that we're in the early stages of growth. Until the explosion happens, we're going to work together. So what is the projection here? When will the explosion happen, and what will that look like?
The first explosion that we're hoping to see is going to happen very, very soon, and that's in the research community. We're hoping to see people discovering new things much faster. We're hoping to see basically people starting to move from the study of how do you build a robot to the study of how do you use a robot. The second real thing that you're going to see after that is moving from academia into companies and seeing people start to build companies on top of that. And that's going to require both progress in the software side and progress in the hardware side. Right? The current price point, there are probably some applications that would justify it, but that's a hard sell. Obviously, they're going to have a lot easier time doing things on lower cost.
Is there a time frame for that, from move from academia to the corporate realm?
I mean, we could guess, but it'd be a pretty
People
guess.
people have been saying that robotics is 10 years away for a long time, and I'm going to stick with that line.
Yeah.
So if I assume you have a PR2 simulator in Gazebo.
Yep.
What are the big differences that people find between what they build in Gazebo and what they do with the actual PR2 that makes it worth having that? I mean, why not spend $4 million on making the simulator so good that every lab in the world can do very reasonable experiments within the simulator?
Two big differences. One is sort of a very technical difference of the way that it simulates friction and picking objects up is just hard. Something like taking the top off of a bottle is not simulated well, but you can fix that in a technical way. The second big one is that no matter what you do in a simulator, it's not actually useful to anybody. And so you need a real robot and real people and real environments to actually be able to go to somebody with muscular dystrophy and say, what will it take to make your life better? And try it. And let him actually say, this is great. I just went 4 days without needing full-time home care. I have a new level of independence. So I think the real reason you need physical robots is you get much richer environments and you get to solve the real problems. Because until you know the problem exists, it's probably not present in the simulation.
Yeah.
There's another robot sneaking in right behind you. PR2.
So ROS is running on a wide variety of robots, not just if you look on ROS.org, there's a wide series of robots running ROS that show people running it, everything ranging from big robots similar to PR2 down to things like iRobot 3, which is basically the Roomba without the back. So that's one great way to do it. The simulator is the second way. So I'd like to introduce you guys to a physical PR2. This is the beast.
This is the robot.
Sorry, is there an Anthony Nielsen in the room?
Yes.
Your car is locked.
So, to feed off the question you asked, there's a transition happening already in this field. Now that we actually have a robot that makes it a software problem, and that's people thinking about applications in robotics as apps. When you think of an app on a phone or on a computer. And when you design an app, people who are trained in product design, for example, they're trained to solve problems. And it's very hard to solve problems in a simulator, but to Eric's point, when you go out in the real world and you talk to people, people just come out of the woodwork with ideas on how you use a robot like this to make their everyday life more productive.
Yeah, I'm thinking, for example, you could have a set of PR2s here at Willow Garage, which are in a lab full of stuff. And then you could let people come in through TAs and watch their programs run on the rental robot after they've tested them. And they wouldn't actually have to have one themselves, but you could let 1,000 people do experiments on physical PR2s if you did something like that. And they could move around the TA, they could sort of like see what's going on.